Hello everyone, this is Mr. Brooks and welcome back to our flipped classroom. We will begin, or continue I should say, with our videos, and we will start off with lesson 10.1, areas of parallelograms and triangles. In this lesson we're going to find the areas of parallelograms and we're going to find the areas of triangles. Hopefully you remember from middle school, or maybe even before that, the area of a rectangle is base times height. We might also even say area of a rectangle is length times width. I learned it as length and width. This book uses base and height. Hopefully, you know, those letters don't matter. It's just one dimension of the rectangle times the other dimension. Area of a parallelogram is also base times height. But it is key to remember that in your parallelogram, the base and the height must be perpendicular. In example 1, we're given two different parallelograms. Please pause the video while you try to figure out the area, or how to get the area of both example 1 part A and example 1 part B. Hopefully in part A, you decide the area is going to be 4 times 5, which is 20. We're not even going to use the 4.5 at all for this problem. Again, base and height must be perpendicular in the area of the parallelogram. So, on part B, we're going to multiply 2 times 3.5. So the area of that parallelogram is going to be 7.0 square centimeters. Okay, now we have quick check number 1. It says find the area of a parallelogram with a base of 12 and a height of 9. Please pause the video while you try to figure this out. Hopefully, you're just going to take area of the parallelogram to be 12 times 9. So hopefully you will agree the area of this parallelogram will be 108 square meters. And that is read square meters, not meters squared. Okay, everything we've done to this point has just been review. Now we're actually going to try to learn something new or do something a little bit more interesting. They want us in example 2 to find the length of segment FC from here to here. All right, we'll call it X. How are we going to find the length of X? Please pause the video while you try to figure this out. Okay, first, hopefully you will agree the area of parallelogram ABCD is just going to be 12 times 10, which would be 120 square inches. That's the area of the parallelogram. Well, another way to get the area of this parallelogram is if you consider the base of the parallelogram to be 13 and the height to be x. So 13 times x has got to equal 120 also. So we would simply divide both sides by 13, and hopefully you're going to find x to be approximately 9.2 inches. Now let's see if you can apply what you learned from example 2 to quick check number 2. In quick check number 2, you got a parallelogram with sides of 15 and 18, and the height corresponding to the side that's 15 is 9. Find the height that corresponds to the side that's 18. Please pause the video while you try to figure this out, and I would strongly recommend drawing yourself a picture. Okay, first I've drawn a parallelogram with sides of length 15 and 18. Then I put the height corresponding to the 15 side to be 9. The blue dotted line is the height corresponding to the 15 side. Now I've got to try to calculate the height corresponding to the 18th side. Well, hopefully you will agree that the area of this parallelogram is going to be 15 times 9, which also has to equal 18 times x. One way to get the area of the parallelogram would be 15 times 9. If 15 is the base, 9 is the height. If 18 is the base, then x is the height. Well, 15 times 9 is 135. And that's got to equal 18x. Now you're going to divide both sides by 18, and you get x to be 7.5. So the height in corresponding to the 18 side is 7.5. Now we have area of a triangle. Area of the triangle is 1/2 base times height, or I sometimes say base times height divided by 2. Same thing. If you want to write it like this, base times height all over 2. That's still area of a triangle. But the key to remember is the same as a parallelogram. Base and height must be perpendicular. In example 3, they're asking us to find the area of this triangle. Please pause the video while you try to figure this out. Alright, hopefully you agree. Area of the triangle is going to be 1/2. The base is 10, and the height is going to be 6.4. You're never even going to need the 4. So you do 1/2 of 10, which is 5. 5 times 6.4, and you get the area of this triangle to be 32 square feet, not feet squared. You say it 32 square feet. Now I'd like you to give it a try. Please pause the video while you try to figure out quick check number 3, the area of the triangle. Again, hopefully you agree. Area of the triangle equals base times height divided by 2. So it's going to be 5 times 12 divided by 2. 60 divided by 2, which is 30. Hopefully you got for an answer 30 square centimeters for the answer to quick check number 2. In example number 4, they're asking us if we're designing a building, buildings have to withstand hurricane force winds of 73 miles per hour or faster. Just a few years ago up by Schoolcraft, they had straight line winds that were over 70 miles an hour. So even in this area, sometimes we get winds that fast, and we have to design buildings that will be strong enough to hold up against those forces. Well, in example 4, they tell us the force of the wind against building in pounds of pressure is going to be 0.004 times the area of the side of the building times the velocity of the wind squared. So, please pause the video while you try to figure out the area of this of the side of the building, and then you're going to plug in 73 miles an hour for V and figure out how many pounds of pressure are against the side of this building if a 73 mile an hour wind is blowing against it. First, to find the area of the side of the building, hopefully you're going to find the area of the rectangle and add it to the area of the square. Well, the area of the, area of the rectangle and add it to the area of the triangle. The area of the rectangle is simply 20 times 12. So the area of the rectangle is going to be 240. Now we have to get area of the triangle. Area of the triangle is going to be base times height divided by 2, which in this case, base is 20, the height is 6, divided by 2. So that's going to end up being 60. So the area of both of these put together is going to be 300 square feet. Now to find the force of a 73 mile an hour wind against the side of the building, we need to use their formula. Force equals 0.004 times the area times the velocity squared. So we'll say 0.004 times 300 times 73 squared. And plug that into our calculator, and you're going to get about 6,400 pounds of pressure. 6,400 pounds of pressure is how strong that wall needs to be. When I pump up my bicycle tire to 55 pounds of pressure, it is rock hard. I mean, there's extreme amount of force coming from the inside of that tube. Can you imagine 6,400 pounds of pressure against that wall. How strong it has to be. And now, in conclusion, quick check number 4 is asking us to find the force of the wind against the side of that same building if the base of the triangle and rectangle are doubled to 40. So please pause the video while you try to figure this out. Again, heights are staying the same. Our base is doubled to 40. So first, let's do area of the triangle. Area of the triangle, base times height, divided by 2. So base 40 times height of 6 divided by 2. So the area of the triangle is going to be 120. Area of the rectangle is just base times height, 40 times 12, which is going to be 480. So the area of the entire figure is going to be 600. Well, again, the force of the wind against the side of the building is going to be 0.004 times area times the velocity of the wind squared. So we're going to say 0.004 area of 600 times 73 squared. And we're going to punch this into our calculator, and we get approximately 12,800 pounds of pressure. And if you remember on the last one, it was 6,400 pounds of pressure approximately. So the force, just by doubling one dimension, the force of the wind against the side of the building has doubled. This concludes Lesson 10.1.